Alright, so in today's class we will cover a radix sort. Okay, so let's get started. So let me write down with radix sort. Let me increase the font size. Yeah. So what is radix sort? The radix sort is one of the oops, linear sorting algorithm for integer. And it functions by sorting the input number given on each digit, and the process adopted by this sort of method is that the number are sorted on least significant digit first. Okay, team, mind this word, the number are sorted on least significant digit first, followed by the second least significant digit, and so on till the most significant digit comes. Right. So what is least significant digit? First try to understand this, because it's going to be a very key concept here. Right. So what is LSD, or what we called as a least significant digit? Okay, I think spelling is a bit wrong. SIGNIFICANT. Okay, which is called as LSD. And we have one more term called as the most significant digit, which is also called as a MSD. We are going to use one more term which is called as a mod. Okay, we will see these three terms which is going to be used very frequently, and that's why I want to explain this first. Right, so what is least significant digit and what's the most significant digit? It's very simple. For example, I'm having $100.50, right? Now if I say, if I increment this 0 by 1, right, or if I increment this 0 by 2 or 3 or 4 or 8 even, is it my this value is going to be change my 100.58 very significantly? Right, no, this number is not going to be changed very drastically. It's almost okay if I write almost okay in terms of, if I say money, 100.50 is almost equal, or not make that much of effect if I write 100.58, right, because this part of this number is least significant, right, is not going to impact very much. However, if I increment this value by 2, right, it's going to be effect, because $100 and $200 are there. I mean, there are huge difference between 100 and $200. If I make it 700 or 800, is going to be a huge difference from $100, right? So the impact of the first digit or the most significant digit is too high, right? So impact of this digit is high. That's why 8 here is, this digit is called as what? Most significant digit. Let me write it. Most significant digit. And the number whose impact is very less is called as least significant digit. Okay. LEASTSIG, right? So this is about least and most significant digit. Now come to mod. uh, The mod is actually what we get as a remainder, right? For example, if I'm having a digit called 72, and if I divide, or if I take a mod of 72, right? So by, let's say, 100 or 10, then it will give me 7.2, right? So in this case, mod would be what? 2, right? So here mod is what we called as a remainder. Whenever we take a mod of any number, then what we get as a remainder is called as a mod of that number. All right. So these are some three terms which I am going to use very extensively in this class. That's why I want to explain it. All right, probably you might be know all these terms very well, but I just want to make sure that everyone know. All right, so now let's get started. Since this radix sort takes the function by sorting the input, and the way or the process it takes is it will take the number, what we have is least significant digit first, and then followed by the most significant digits, right? So let me take a fresh page. Okay, so let me write down some number. For example, let me take 10, and let me increase the size first. Okay, so the number is like 10, then 180, then 72, then for example 45, then 136, or 8, and then 39, for example. I've just taken some random numbers, right? Now, before we proceed, let me explain you the key concept here, right? The key concept is, first of all, on the very first instance, we will take a number, for example, let's say 10, right? And then we will take a mod of this number, right? So the second step would be, this is my first step, let's say. Second step would be, we will take the mod of this number by 10, right? Or I can say, if it's going to be a bit confused, let me take a 45 number, right? So every number on the first phase is going to be mod by 10. Okay, either it's 136 or 8 or any number. And then third step is, we will divide what we have in mod by 1. Alright, for example, in this case, if I take a mod of 45 by 10, then it comes as what? It comes as 5. Alright, and if I divide 5 by 1, it will comes as 5. Okay, so in this way we will proceed our phase 1, right? After that we will get a sorted array. I'm just going to write a diagram, or I can say some sort of algorithm that will give you some picture of what I'm going to do, right? So this will give you a sorted array of phase 1, and after that again I repeat the same process, let's say, of this sorted array. Okay, let me make this like this. Of this sorted array, and we take a first number. Let's say my first element of my sorted array would be, or I can say this is my first sorted array. Okay, this sorted array may not contains all the element in sorted form. Okay, may not contains all element in sorted form. So we will again move towards our phase 2, and in that we will again take a mod, but this time we will increment the value by one more zero, right? So earlier it was 10, now it comes as 100. So uh, this comes as 80, and here also we will increment the value of division by a 0. So here what we have as a remainder, earlier it was dividing with 1, now we are dividing with 10, right? Earlier it was 1 here, you can see, now we are going to divide by 10. Alright, so this gives me 8, and again we got a sorted array that again may not be in sorted form. Oops, let me write down here, right? So after first, again my second sorted array may not contain all the element in sorted form, so we will follow again the same procedure. Like if the first element of my sorted array is, for example, as a 45, then we will take a mod, but with one more 0 this time. Earlier it was 100, now again we will take a mod with 1000. Okay, so my second step would be take a mod with 1000. Alright, so this gives me remainder as a 45, and we will divide 45 by 100. Earlier it was 10, right? Before earlier it was 1. So as we move forward, we will increment the value of 0 by 1, right? So now it comes as a dot 45, or I can say 0.45. Right, so in this way we will move forward, and again we find a sorted array. Most of the times it seems that or I can say it seems that whenever we have a figure in three figures, like let's say for example here we have 180, right? So we have a three figures, then in third time the array what we receive would be the sorted form, right? So it's the basic layout about how we are going to move forward, right? So the first step would be, let me explain you again. First, the first step is we will take a number, any number, or let's say in our case, if I start from 10, right? Most of the times we will start from left hand side, by the way, right? So we will, but here I am just taking any number just for the sake of an understanding and as an example. So here if I take a 45, then we will take a mod of this number and divide the number by 1 of what number we have received in a mod, and then in that way we will sort the array, right? How we are going to sort, we will see, right? We are going to make a linked list also, and in which we are going to store this value. We will see all this in our next slide. right? But I'm just going to explain you what the overall layout. First of all, we will mod by 10 and divide by 1. Next step, we will mod by 100 and divide by 10. And third step would be we will take mod by 1000 and divide by 100, right? And then in this way we will find, or we will get a sorted array. This is the basic concept or the whole soul concept of the radix sort, right? If you have any doubt or any confusion, it will definitely clear when I'm going to explain you in our next slide. All right, so let's open my next fresh page. uh, yes, okay, let me write it down once again. My first, oops, my array would be, let me increase the font size, okay, 10, then 180, then 72, then 45, then 136, then 8, then 39. All right, so let's get started. So before we are going to start, let me give you one more thing. Okay, what was that? See, in this radix sort, we will consider a linked list which carries a significant number from 0 to 9. So let's draw a linked list, right? So let me draw a linked list for you. It's like let me, yeah, let's say this is my 0th. This linked list contains the significant digit from 0 to 9. Okay, 3, then 4, 5, 6, 7, 8, and suppose this is my ninth part. Just let me make it here, right? So it's not very look like a very equally divided, but please bear with me. Okay, so this is my linked list which contains a significant value from 0 to 9, which is actually I'm going to use uh, to sort out my array using radix sort. Now let's take our very first digit from the left side, which is 10. All right. Let me write like this. Okay, so if I take my very first digit 10, so my first rule is we need to take a mod by 10 and divide by 1. Okay, so I will take 10 mod by 10, right, which gives me what? Remainder as a 0, right? And then if I divide 0 by 1, I will get what? 0, right? Team, this number, this 0 number is the place where I actually going to put my this number. Okay, this gives me the place where I'm going to use my digit 10 from the array, right? So let me put 10 here. Okay, now again Let me take another number which is 180. It's good if I take same color, otherwise it's going to be very hectic if I always change my number color every time. So as per the rule, let me take a mod of 180, right, which gives me again 0, right, 180 mod 10, which gives me remainder as a 0, and if I divide 0 by 1, it gives me 0, right. So the next number which I uh, got at 0th place will be 180. All right, now third number is 72, right. So 72 mod 10 equal to 2 as a remainder, and if I divide 2 by 1, this will give me what? 2. Alright, so my next number place is second, which will be